Okay, we are now recording the video. All right, so when you look on your Canvas, you will see a thing right here that says quiz and recorded video. So the quiz will be very simple, and the recorded video will be there for those of you who weren't able to participate in today's class live. You'll be able to watch the video. And then, so if you participate today or watch the video, the quiz should be very, very easy. The main assignment that I want you to do is the one about resistors in series voltage dividers, basics of electricity. You'll see those on Canvas. So does anybody have any questions about what you see on Canvas and how things are working for you here? Is the online class format working out okay for you? So I'm seeing lots of yeses. So Marshall is saying not really. Marshall, can you elaborate on why it's not working out for you? If you want to turn on your microphone and tell us verbally, that's better. You're unmotivated. Okay, well, if you want, I'll come over to your house with some high voltage electrical stuff and see if I can shock you into being motivation. Oh, it's your chill place. Huh? Okay, so I guess you don't want me to shock you then. Well, you're gonna have to solve that problem yourself there, Marshall. Okay. Cattle prod, yes, high voltage, that's it exactly. All right, so tell you what, let's get on with today's class. Okay, so first thing I want to do is let's talk about the online quiz. This is, or actually, I'm sorry, this is the homework assignment that was due today. So hopefully you guys all did that one okay. So, all right, so question number one was what does open source mean? So I hope that you guys realize that the correct answer here is the second one down. Open source means it's something that is free and available for anybody to use. You don't need to have a special license, special permission. And the reason that open source is important for Arduino people is because the Arduino code is open source. That means that anybody who wants can use the Arduino program. You don't have to pay a licensing fee, and people can contribute good ideas. I'm hearing somebody's got their mic on. Van, that might be you. I'm going to mute you. Kaya, it might be you. Actually, tell you what, I'm just going to mute everybody. Okay, so everybody is now muted. So if you want to ask a question, you can go ahead and unmute yourself. But now I'm not hearing that funny feedback that I was hearing before. Okay, so everybody, hopefully you got that question right. The order may be a little bit different for you. Canvas automatically it shuffles the order. So it may not have been the second one for you. Okay, so the Arduino software is all open source. That's why it's important. Okay. Next one, question number 2 here. Right, so what are ohms? All right, hopefully you guys all got that one right. And it's not the sound that's made by a Buddhist monk. Ohms are the units that we use when we're measuring electrical resistance. Okay, next one. What 2 parts must every Arduino program contain? All right, the correct answer for that one is the third one down. Can you guys see? All right, see the little marker, my little cursor here. So every Arduino program has to have a void setup and it has to have a void loop. Anything that you put in the setup part of the code, the Arduino will do once and only once. Anything that you put in the loop part of the code, the Arduino will just keep cycling that again and again and again until you turn off the Arduino. All right, next one. What is a microchip? All right, a microchip is it's the last one down here. It's the small electrical component that can manipulate data. So let's see, where did I put my Arduino? I had an Arduino sitting out here a moment ago. Oh, here it is, okay. Okay, so on the Arduino, this thing right here, that is the microchip. The rest of this stuff is just stuff that feeds information into it and out of it. But this thing right here, the chip there, that is a little piece of silicon that's got some really cool stuff in it. And so it acts as a little brain, and you can program it to do various things depending on what the input and the outputs are. So that is a microchip, and that's what I spent my career making. Before I retired and became a teacher, I made microchips, and they're super cool. Making them was a lot of fun. Okay, what is voltage? All right, that one was on the follow-up quiz after Wednesday's meeting, and pretty much everybody got that right. So the best way to think about that one is this second one down here. Think of it as electrical pressure. It's not the amount of electricity flowing through a circuit. That would be current. It's not the amount of power that's being used. That would be watts. It's not the amount of work that's being done. That would be joules. So these are terms that I'm sure don't make sense to you, joules and watts and things. When you take my physics class next year, which I hope you do, or the year after that perhaps, but when you take my physics class, you're going to learn about those types of things. But right now, we're going to keep it really simple. All we're going to do is, all we need to know is the voltage is the pressure that pushes the current through there. Okay, next one. All right. So I gave you a bunch of things and you needed to decide whether they were input or output devices. So a computer mouse would be an input device. A computer screen that has touch screen capability could be both. If you touch the screen, like right now on my computer, I have a touch screen. So as I move this thing around, I'm touching the screen to do that. So I'm using it as an input device, but it's displaying information to me. So that's an output device. Okay, a computer screen without touchscreen capability would obviously be output only. Microphone would be an input device. A printer would be an output device. An on-off switch would be an input device. A buzzer would be an output device. An LED would be output. A light sensor would be an input device. And a motor would be an output device. So I trust everybody's good on that. Tell you what, let me just do a periodic check here. Can one or two of you just give me a confirmation that you're able to hear me? Because I know sometimes the internet doesn't work too well. Okay, good. Thank you very much for that. Glad to hear that it's working. All right, let's go to our next thing here. Okay, so what is an integrated development environment, also called an IDE? All right, that's the software that you use to write your computer program. So the Arduino has its own IDE, its own integrated development program environment. So that's the program that you use to write the software. And those of you that are taking Mr. Webster's computer science classes, you know that there are different types of IDEs for the other things. But for Arduino, it's the one that you can download. And because it's open source, it's free. You don't have to pay for it. Open source is really nice. Okay, question number 8 here. What is electrical current? Okay, so that's the amount of electricity that's flowing past a certain point. So if you ask what units are we using when we measure it, there's two ways to answer that. One way is you could say that it's the number of coulombs per second. So remember, a coulomb is like a gallon of electrons. All right, so the number of coulombs per second. But people who work with electricity day in, day out, they don't call it that just because it's awkward to say. It's faster to call it an amp. So an amp is another way of saying coulombs per second. So it's the amount of electricity that flows past a certain point. Okay, question number 9, the difference between binary and analog. All right, so I'm hoping that you guys all got that correct in today's homework. After we finish the meeting here, I'll log off and we'll talk about it. But basically, binary is where you have two possible states. It can either be fully on or fully off, but there's no in between allowed. Okay, where analog does allow for in between stuff. With analog, it is possible that you, instead of being 100% on, you might only be 63.2% on, right? So computers store everything in binary form, a bunch of digital ones and zeros. But the sensors that are feeding the information to the computer, those might be sending it some intermediate value. It might not be fully on, might fully off. It might only be 27% on. Okay, so you need to understand the difference between binary and analog. Okay, and then the last question in the assignment was for you to write the Arduino code that does what you see here on the screen. So Danny's asking me if I said digital instead of binary. Digital and binary are terms that can be used interchangeably. They both mean the same thing. Okay, thank you for asking that question. All right, so the last question on the homework assignment was this. So I haven't yet checked to see what you guys did, but I'm hoping that you all got that right. So if you learned what you were supposed to have learned prior to the spring break, everyone should have been able to write the code that does this. If you did it in the most efficient format, you should have used what's called a nested for loop, where you have a for loop inside of another for loop. That's the most efficient way to do it. It is possible to do it without using that, but boy, is it going to be a lot of lines of code. So I hope that you guys all use nested for loops. So can you give me a little feedback here? And it's hard teaching when I can't see your eyes, so I don't know whether you're getting it. Can you just type in how many of you used nested for loops when you did problem number 10? Okay, good. Okay, excellent. All right, I'm seeing lots of people saying you did. Very, very good. Okay. All right, now. Okay, you hopefully remember that on Wednesday, I talked about the reason for what we're about to do. So the first burglar alarm, okay, the first burglar alarm that everybody made, you used an Arduino, and we used this solar panel, which we connected up to the Arduino. And so the Arduino just looked at the solar panel, and if it saw that the solar panel was shadowed, then it set off the alarm, and if it wasn't, then it didn't. So you didn't really need to know any electronics whatsoever to make this Rev1 burglar alarm. It was all you had to know was how to program an Arduino, which you guys did pretty well on that. Okay, now the problem with that is if we try to go into business selling burglar alarms that are based off of this, our competition could easily undercut us in price, because these solar panels are pretty expensive comparatively. And so we have to pay a high price to our supplier to buy the solar panels. That means if we resell them as part of our burglar alarm, we're going to have to charge a lot of money for our burglar alarm. Now, if our competition knows something about electronics, then they can figure out a way to take this expensive burglar alarm and replace it with this little tiny thing that right here, I don't know if you can see, this little tiny thing, way smaller and way cheaper than a burglar alarm. This thing is a photoresistor, and what it does is it provides some resistance, but the amount of resistance that it supplies is different depending on whether there's light hitting it on or not. Okay, so if there's light hitting on this photoresistor, then the resistance is a certain number of ohms. And if I put my hand in front of it so that it's not seeing light anymore, the resistance value changes. Okay, and so we could use this to make a burglar alarm, and it would turn out that our burglar alarm would be a heck of a lot less expensive, because these photoresistors, you could buy them in bulk for a penny a piece, where these solar cells, photocells, solar panels, they cost a heck of a lot more than that. Okay, so what my plan was prior to the coronavirus shutdown was that we're going to take our Rev1 burglar alarm, which uses this expensive solar panel, throw the expensive solar panel away, and replace it with this inexpensive photoresistor, but we can't do it unless we understand some electronics. So I'm going to still go with that plan, even though we may not be able to actually make the Rev2 burglar alarm at home, because I'm sure you guys don't have all of the equipment that you need. We're still going to design it, and the plan is that we're still going to hopefully understand how it works. Okay, so before we do that, we have to learn about electronics, because it requires some electronic skill in order to do that. So hang on a sec while I've got two screens here. That's why I keep looking off to the side here. Okay, so let's learn a little bit about electronics. All right, so what you see here is the same screen that we talked about last time. It's the page from the Arduino primer. It talks about Ohm's law, and you see the little picture here where you see the water flowing through here. This is the analogy. Water flowing through this pipe here is the very good equivalent for electricity flowing from the battery through the light here. Okay, so I'm hoping that everybody understood that. So let's move on to some examples now. Okay, so what you see here is a schematic. Remember that this symbol that you're seeing right here, this is a shorthand way of representing a battery. The long side here is always the plus side of the battery. The short side is always the negative side of the battery. Up here we have a switch, and then over here is a resistor. Now the symbol that you see here, that's a generic symbol for a resistor. That could be anything that uses electricity. It could be a light bulb, could be a motor, could be your smartphone charging, could be absolutely anything that uses up electricity. All right, so, okay, I want everybody to do a little problem here. If we were to take a 12-volt battery and we hook it up to a resistor that has 3 ohms of resistance, I want you guys to tell me how much electrical current is going to flow through the switch. Now, in order to do that, you're going to need Ohm's law. Remember Ohm's law here. Okay, so the one up at the top here, I stands for current, V is voltage, R is resistance. So we're going to use Ohm's law. The current is equal to V divided by R. Okay, so I want to know what is the current if we have a battery that has 12 volts. All right, okay, very good. Okay, no hesitation there, 4 amps, which is the same thing as 4 coulombs per second, but usually people who work with electricity are going to call it 4 amps. Okay, that was easy. You didn't even need a calculator for that one. Okay, 4 amps was in fact the answer. All right, now, I don't like writing out the word volts and amps every time here. So you can see, so if I've got 12 volts, right? So I'm going to abbreviate that as 12V, makes sense. I've got 4 amps, which I could abbreviate as 4A. So if I want to write my answer as 30 ohms, would it not make sense that I'm sorry, 3 ohms, I'm getting ahead of myself here. All right, so would it not make sense that I could abbreviate it as 3 O's? Is that not a logical way to do things? Oh, people are saying no, okay. So yeah, obviously that's not a good idea, because if I write it as 3 O's, people look at it and they say, well, is it 3 O's or is it 30? So obviously not a good idea. And I see a lot of you are way ahead of me on this. So what we're going to do is, instead of calling it 3 O's, we're going to use the Greek letter omega, which omega sounds like ohms, right? So it's a logical choice. So it's this upside down horseshoe that you see right here. Okay. All right. So that symbol is the Greek letter omega. So that's what we're going to use whenever we want to abbreviate ohms. So three upside down horseshoes there is 3 ohms. All right. Okay, so now here's a circuit where I've got 220 ohm resistor, and I've also got it connected up with the 100 ohm resistor. So instead of having one resistor, I've got 2 resistors now. So how am I going to figure out the current now? Let's see what you guys come up with. How many ohms of electricity? Yeah, okay. Wig point, okay, I'll count that as 1 wig point. How many amps of current are going to flow if we have a circuit with 2 resistors in it? Okay, so, all right, it looks like Danny and Caden both. Okay, so Danny, I like the way you said it. Danny is suggesting that we can just add them together. He's saying that the total resistance is going to be just the sum of the 2. So these 2 resistors behave as if there was just 1 resistor, where the value of that 1 resistor is 320 amps. And I see that Eve is already ahead of me here, as is David. Okay, so what we're going to do then is, oh, by the way, before we go on, let me say that when you hook them up this way, this is called hooking them up in series. We'll talk more about that later. Okay, so the total current then is just the number of volts, which is 9, divided by the total resistance, which is 200 plus 100. Okay, so the answer then is 0.028 amps. Now I see that Van and somebody else here, who was that? Okay, it's scrolled up here. Okay, so David. So Van and David, they both decided that instead of writing their answer as 0.028, they wanted to call it 28 milliamps. Okay, okay, here we go. All right, so that is an important thing that you guys need to know. It's very commonly going to happen that when we calculate our answer and we get 0.028, I might call it 0.028, but I also might instead call it 28 milliamps. And I trust that you guys can do the conversion. Milliamps to amps is the same thing as millimeters to meters. I trust that in your other classes you've done unit conversions, right? So if I wanted to measure something and it was 28 millimeters long, okay, that would be the same thing as 0.028 meters. So millimeters, milliamps work the same way as millimeters, milliamps, that work the same way. But here, this is really important right here. When you are using Ohm's law, when you're using the equation I equals V over R, you must put the numbers in using real volts, real amps, real ohms. You cannot put them in using milliamps or kilovolts or mega ohms or whatever. It's got to be in regular. Okay, so make sure that you guys understand that. Uh-oh, no. That's 2. Okay, let me fix that. Thank you for pointing that out. Okay, great. We're up to 2 wig points now. And by the way, I brought the wig, and it looks like it's a good thing I did, because one more wig point and I'm going to be wearing that stupid thing. Okay, so thank you for correcting that typo. Yes. Okay, but I still got one more to go. So hopefully I can make it through the class here without having to wear the wig. Okay, so let's move on. Okay, now here is something that we have not yet talked about. And it's something that's crucial for understanding how to make our Rev2 burglar alarm. Okay, so we've got a circuit here, and we have now figured out that we've got 28 milliamps flowing through the circuit. And I need you to understand that there's going to be 28 milliamps everywhere in the circuit. It doesn't matter where we look in the circuit. At any point here, the current it's the same. Whenever you have a circuit that only has one loop, the current is the same everywhere in that loop. Okay, so I'm interested in voltage drop. I want to know what is the voltage drop in each resistor? So let's take them one at a time here. So, okay, I'll just put it, okay, right here. Okay, so this resistor on top, the one that's 220 ohms, I want to know what is the change in electrical pressure. So on the one side, it's feeling 9 volts of electrical pressure because this battery right here is putting out 9 volts of pressure or voltage. So on the left side of this resistor, there's 9 volts of electrical pressure. But over on the right side, it's not going to be 0. If there was only one resistor, it would be 0. But because there's 2 resistors, so over on the left side, it's 9 volts here, and then it drops down to some intermediate voltage here. And then when it goes over the last resistor, that's when the electrical pressure drops to 0. So I want to know what is the voltage drop. I want to know what is the difference in voltage just across this one resistor. Okay, so Caden is suggesting that it's 6.16, and looks like Van is agreeing. Luke is suggesting linear proportioning, which is an interesting way of thinking about it. I like that. Okay, so I'm guessing that the way that you guys did this, or at least I'm hoping that the way you did this, was you took Ohm's law, which the way that I like to remember it is I equals V over R. But you guys are good at algebra, so you can rearrange that. So if I take this equation and I multiply both sides by R, then what I get is I get the V all by itself. And over on the other side of the equal sign, I have R times I. So this is Ohm's law just rearranged, all right? So I know that the resistance for this upper guy here is 220, okay? The current that's flowing through that resistor is 28 milliamps, which I must not write as 28 milliamps. I have to write it as 0.028 amps, okay? So if I use the modified version of Ohm's law, then I can figure out that the voltage drop across this guy is 6.2 amps. Actually, it's 6.16, but I'm only going to use 2 significant figures. My input numbers here I have 2 significant figures in this guy, and I have 2 significant figures in this guy. So I'm going to write my answer with only 2 sig figs. But those of you that are saying that it's 6.16, that is the more correct answer. But if we follow the sig fig rules, 2.6. Okay, and then down here at the bottom, you can see if I do the same thing for this resistor here, that means I've got a voltage drop across that one resistor of 2.18. Would I add the 2 volts? Yeah, I would. And that's what I've done. So if you take the 2.8 volts here and add that to the 6.2 volts here, you will not be surprised to find that it adds up to 9 volts. It would be a problem if it didn't. All right. So does the diagram have 2? Oh, does it really? Oh, please don't tell me it does. Oh, no. It does. Well, you know what that means. Okay, hang on. I made this up late last night. Okay, here we go. Rats. Okay. All right, let me go in and fix that. Okay.
Yay, finally. Woo-hoo.
Yay. Is this the first time that I've worn this in this class? I thought I've worn it before.
Yeah, that is the first time.
It is the first time? Oh, great. Okay, well, all right. So I see I'm open to ridicule now. Well, that's my fault for not being more careful. What can I say? Oh, better change this one down here too. All right. And okay. All right. So now we understand. So the voltage drop across one resistor is the difference in pressure. So over on the left side here of this resistor where I've got my cursor right now, the absolute voltage is 9 volts. It drops by 6.2 when it crosses over here. So over on this side then, on the right side of this resistor, the absolute voltage is going to be whatever 9 minus 6.2 is, which is going to work out to be 2.8 volts. Okay, and now if I look at the resistor on the bottom here, okay, So the voltage drop across that resistor is 2.8. Now, down here on the bottom part of this resistor, it's connected up to the negative side of the battery. So the absolute voltage down here is 0, and the voltage difference across here is 2.8. So my intermediate voltage here is 2.8 volts. Okay, I'm guessing everybody, you guys are ridiculing me in the comment section here, but I deserved it. I deserved it. Okay, so now that you understand that, now we can get into what we call a voltage divider. This is the key to making our Rev2 burglar alarm using an inexpensive photoresistor instead of an expensive solar panel. We need to understand how voltage dividers work. Oh no, you took a picture of me? Shame on you. Okay. If that picture ends up in the yearbook, I am going to be very embarrassed. And we certainly don't want me to be very embarrassed, do we? No, it looks like you guys actually do want me to be very embarrassed. Oh, well, okay. All right, let's move on. Okay, now, here's a problem I want you guys to think about. Okay, so I'm going to take 2 resistors. I'm going to hook them up with a battery. And over here on the right side, you can see what the voltages are. So I'm going to take a 12.4 battery, and R1, which is the resistor up on top, is 750 ohms. R2, which is the resistor down on the bottom, is 100 ohms. So V out, okay, V out is the voltage difference across the lower resistor. And the reason I call it V out is because I could take a wire and I could connect up a wire up here, up the top part, and connect the other end of the wire down here. And I could use that as the output voltage, which I would then feed into some other thing, like, for instance, an Arduino. Okay, so I'm going to use that as the input to my Arduino. So it's the output from my voltage divider becomes the input from my Arduino. Okay, so hopefully you guys are ahead of me here. So can anybody calculate how many volts will be across my R2 resistor there? Let's see what you guys come up with. Not seeing any numbers appearing on the screen yet. Come on, people, do some thinking. There are at least 2 of you in this class that I know can do this because you took my electronics class. The rest of you might need a little help. I'll give you 1 more minute to think about it. I want everybody to try this. Try it on your own, but you know, in a minute I'll tell you how to do it. But I want to see if you can do it on your own. Yeah, hey Marshall, you come on yourself here. All right, so Danny is thinking that it's 0.014 volts. So Danny, I suggest you rethink that. The voltage is going to be a little higher than that. Did you perhaps calculate the current? Is that what you might have calculated? Okay, so Eve is thinking that it's 1.46 volts. Let's see if, okay, so Danny, okay, so you're thinking that's a mistake you made. All right, good. Let's tell you what, it's kind of awkward to have my 2 screens here separated by more than I would like. Let's see. Okay. Anybody else want to chime in? So Eve is proposing that the voltage across it is 1.46 volts. Does anybody second that motion? Or is anyone opposed to that? Okay, David is saying yay. Let's get a few more people chiming in before I move on. Okay, so Simon is seconding it. Okay, all right, so let's see if we can figure out, those of you that didn't figure it out. Okay, so here is my answer. But the important thing is and my answer is actually not different than Eve's. Eve gave her answer using 3 sig figs. I gave mine using 2. They are the same answer, I just rounded off. Okay, so let's see, how can we figure that out? All right, so the way that I recommend we do it is, first of all, actually, let me open up a text box here. Okay, so what I'm going to do here is I'm going to say, if it'll let me. Okay, you guys agree the total resistance is 850. I just add them all up. Okay, so what do I do next? Okay, so the next thing I do is I calculate the current. The current is I, which is given by V divided by R. Okay, so 850. Oh, so the voltage is 9. So 9 divided by 850 equals, okay, so 9 divided by 850. Okay, so I'm getting 0.0, or I'm sorry, yeah, 0.0106. Okay, and by the way, that's going to be amps. I should probably put my units in here. Okay, so what I'm getting is that the current that is flowing through this circuit is 0.0. Now you understand why people use milliamps. It's so hard to say 0.0106 amps. It's a whole lot easier to just say 10.6 milliamps, a whole lot easier there. Okay, so now we know how much current is flowing through it, but that's not what I was after. I wanted to know what is the voltage drop across it. So what I need to do next is I take the other form of voltage of Ohm's law, which says that the voltage is equal to I times R. Okay, so now I know the current is 106 times the resistance. And so I'm interested in R2. I want to know the voltage across R2, and the value of R2 is 100 ohms. Okay, and so when I do that, I get, well, actually, I don't need a calculator for that. I get, okay, yeah. So I get 1 point, wait a minute. What okay, help me out here, guys. What did I do wrong? Oh, it's not 9 volts. Good thing I'm wearing the wig. What more do you want? Okay, let me try that. Thank you for your help, guys. It's not a 9-volt battery anymore. It's a 12.4 volt battery. Okay, that makes all the difference in the world. Teaching online here is a lot harder than it might look. Okay, let's try that again. 12.4 divided by 850. Okay, so thank you. So it's 0.0146. Okay. I have a feeling that if I do this online teaching every day, I'm going to be wearing this stupid wig every single day. Okay. Oh, okay. Okay. Wait. Okay. I am really, I'm on, okay. Maybe I need to put a hat on top of my wig. Yes, it is hard teaching with this wig on. I agree completely. Okay. So 1.46 volts, that's the answer. And now I'm going to call that 1.5 volts. And the reason I do that is because if you look at my input numbers, okay, 750, it only has 2 sig figs. And so whenever you're doing math, you don't want to express your answer with more sig figs than you think is reasonable. Now, some of you are going to look at this number and you're going to say, wait a minute, 100 only has 1 sig fig in it. So yeah, so I'm going to assume that 100 is actually, I know that it's 100 with 2 sig figs worth of accuracy. Okay, so the better way to write that is write it as 1.0 times 10 to the second is a better way to write that. Okay, so now you can see, so my numbers, my least significant figure there has 2 sig figs. But tell you what, I'm not going to worry with you guys, your ninth graders. I'm not going to worry too much about sig figs. If you want to write the answer as 1.46, I'll give you credit. Okay, so give me some thumbs up now. You guys understand how it is that we figured out that our voltage divider here, our output voltage is going to be 1.5 or 1.46. Okay, all right, everybody's saying, yeah, that makes sense. Okay, so let's do another one here. Okay, here's a new problem. The circuit looks exactly the same, except this time the values are different. This time our voltage is 9.1. The resistor up on top has 150 ohms of resistance. The resistor on the bottom has 240 ohms of resistance. So I want to know, what will V out be? I'll give you guys a minute. Let's see if you can figure out what is the output voltage going to be in this case. All right, so Danny is thinking that it's 2.3 with a whole lot of threes repeating there. Let's see if other people agree. I'll give you a little time here. I need somebody else to chime in. So remember the sequence. First thing you do is calculate the total resistance. Second thing you do is calculate what's the current that's going to be flowing through the circuit. And then the last thing you do is you use that current value together with the value of the resistor that we want to know what's the voltage across it. And from that, we can calculate what the voltage drop is. Okay, so, oh, we got some disagreement here. Okay, so Tristan is thinking that it's 5.6 volts. So David is suggesting that the current that's flowing through there is 23 milliamps. That may or may not be correct. I'm not going to say one way or the other. I'll let you guys slug it out. Okay, Luke is chiming in. He agrees that it's 5.6 volts. Let's see one or two more people. I want to see what your input is. Okay, so it looks like people are agreeing 5.6. Okay, all right, and let's see what I got. Hey, I got the same answer you did. Okay, does that mean I can take the wig off? If I get the right answer, do I get to take the wig off? Oh, no. Oh, you guys are so mean to me. I'm going to tell Mr. Wilson how mean you guys are to me. Okay. All right. Now, we've still got about 13 minutes left. Okay, so I want to do one more problem. It's also a voltage divider problem, but I'm just going to approach from a different angle. And let's see if you guys can handle this. Okay, so this time around, I'm not asking you what the output voltage is. I'm telling you what I want the output voltage to be. Okay, so basically what's happening here is I've got a 12-volt battery. Over here on the left side, I got a 12-volt battery. But I've got some device that needs only 5 volts. So if I take my device and I hook it up directly to my 12-volt battery, I'm going to burn out my device because 12 volts is too much voltage for my device. Okay, so my device needs 5 volts. So what I'm going to do then is I'm going to build a voltage divider that will step down the voltage from this 12 down to 5. Okay, so I'm going to assume here that I've got a bunch of resistors. And one of my resistors has a value of 360 ohms. And then I'm going to assume that I have a whole bunch of other resistors. So I need to know what value of resistance should I pick for R1 in order that the output voltage here will be 5 volts like I want it to be. Okay, so here it's the same problem. I'm just approaching it from a different direction. So I'll give you guys a couple minutes to think about it. How would you recommend that we should approach this problem in order to figure out what value we need to use for R1 in order to make it that our output voltage will be 5 volts? Is it the same sequence again? Well, we're going to use the same steps, but probably not in the same sequence. We're going to use the same equations. So Yeah, use algebra. Thank you, Luke. That's a very insightful comment there. If anybody wants to turn on their microphone and speak, I'd be open to that. Okay, so Eve is suggesting that we use 504. Luke is seconding Eve's motion. Dave is in. Okay, can one of you guys turn on your microphone and explain to us how you did that? Or if you want, type it in, but microphones are better.
Yes. Can you hear me?
Yeah, I can hear you. Go ahead.
Okay. Well, you just use algebra. So if you use, yeah, I am. So first you calculated over the entire circuit. So 5 equals whatever your current is times 300. No, hold on. I took some shortcuts and I'm not sure if I can remember them. You do. So your current is going to be 12 over 360 plus x, where x is your r sub 1. So then if you put that into your second equation, then you have 5 equals 12 over 360 plus x times 360. So then divide by 5, multiply by... Yeah, so then divide by 5, multiply by 360 plus x, and then subtract 360, and you get 504.
Okay. What you just said, it sounds like it's 100% correct, but I'm willing to bet that most of the people are sitting there saying, huh? So what you said is not wrong at all. And if you are good at math and you're comfortable with algebra, that's a great way to do it. Let me suggest an alternate approach that's actually the same approach, but it's a step-by-step approach that I think is easier. It doesn't require as much math skill, but it'll get you to the same place. Okay, so here's the way that I recommend that you approach it. Okay, so first thing we're going to do is we are going to calculate what is the current. So we know that the current equals V over R. Okay, and so I'm going to look just at my R2 because I know the value of R2. I know that R2 is 360 ohms. And I know that the voltage that I want across R2 is 5 volts. So I'm going to take the voltage that I want to be across R2, and I'm going to divide it by whatever R2's value is, which is 360. Okay, and let's see what I get. So 5 divided by 360. Okay, so I get a current of 0.013, and let's throw in an extra sig fig just for good measure. I see that I've got a bunch of 8s after that, so I'm just going to round it off to 9. So I'm going to say that the current that's flowing through that resistor has to be 13.9 milliamps. Okay. Now, that same current is going to flow through R2, provided, you see my note down here that says assume that whatever you connect to V out draws negligible current. Okay, that's a really important assumption. But if whatever I hook up to my output here doesn't draw enough current to worry about, then the amount of current through R1 is going to be the same. So that's equal to the current that's going, well, let me just say that's the current that goes through R2, but it's also going to be the current that goes through R1. Okay, so now, why is that important? Well, now let's think. If we know that our total voltage is 12, and we know that the voltage across R1 or R2 here has to be 5, so what would the voltage across R1 have to be? We know the total voltage has to be 12. So we know that we lose 5 volts across R2. So do you guys agree that the voltage across R1 has to be 7? So does that, you guys agree that makes sense? Give me a couple of yays or nays so I know that you guys are awake. Okay, good. All right, so now I know the voltage across R1 must be 7 volts. So now that I know that, now I can easily find out what the resistance is for R1. So again, I'm going to need to use a little bit of algebra here. So My normal, the way that I like to remember Ohm's law is I equals V over R. If you guys use a little bit of algebra there, if you multiply both sides by R and divide both sides by I, you guys agree that you can get R equals V over I? You guys agree I haven't violated any laws of mathematics or algebra by doing that? Okay, so now I'm going to focus in on just R1. So I want to know what R1 is. Now I've logically figured out that the voltage across R1 must be whatever 12 minus 5 is, so it's 7. So the voltage is 7, and the current that's flowing through R1 has to be the same as the current that flowed through R2. So that's 0.0139. Okay, so let me give out my calculator here. So 7 divided by whatever my last answer was. So I'm getting 504. Okay, and now this is ohms here. So let me go in here and get my ohm symbol. You guys see how I did that? Okay, so 504 ohms is the answer. Let me just make that nice and big. All right. So those of you that said 504, let's see, that was pretty much, that was what you guys said, right? Yep, okay. So it makes sense? All right, so we're almost out of time here. Actually, class session really should be an hour and a half, but I think that's too long. So I'm gonna try and finish by noon every day. I don't guarantee I'll always succeed, but I think today looks like I'm gonna succeed. All right, so what is your homework assignment? Okay, let's go back to here. Okay, yeah, oh, it's not, doesn't want to come up. Okay, so ignore that. Okay, so let's just go back to here. Okay, boy, that wig is horrible. You guys, you are so mean to me, making me wear this thing. Okay, so your homework assignment, just go on Canvas. You're going to see on Canvas that I posted some stuff to help you. If you have any questions about what you see on Canvas, let me know. Remember that you are going to have to take a quiz later this afternoon. I haven't yet posted the quiz, because what I like to do is I like to post the quiz and the recording of today's session together side by side. And also, I don't want to make up the quiz questions until the day's online class is ended. So the daily quiz will be really simple. It'll be, you know, stuff like, what color shirt am I wearing? Or it might be, what was the question that I missed that made me wear the wig? You know, it'll be that kind of stuff. So it should be really simple. And then the homework assignment will be posted on Canvas. So with that being said, let me come back here to my chat here. Oh, I see Brian. Hello, Brian. Oh, okay. So you guys got any questions here? Riker's dad is jealous of how much hair I have. And John is not the least bit sorry here. Okay. So what's the sequence for the voltage divider? All right, so all I can recommend is just go back and watch this video again. When I post the recording, go back and watch it a second time. Oh, also, when you look on Canvas, you're going to see that I have posted a video from Khan Academy where they talk about voltage dividers. What you're going to find is that the people at Khan Academy, they approach the problem almost exactly the same way that Luke tried to explain it. And that's a great approach. The reason that I like my approach better is that you don't have to use quite as much math. The equations you work with are a lot simpler in mine. But if you're comfortable with math and you don't mind equations that are a little bit more complex, you can use the Khan Academy approach, which is online, which is basically the same as Luke's approach. Okay, so I'm not seeing any more questions being posted. So first thing I'm going to do here is I'm going to end the recording. Okay, so here I'm going to stop the recording. And then after I do that, I'm going to stop the class.